راح ناخد meeting number 9 بس هو بال LMS اسمه meeting 13 وحتى بداخل راح تشوفوا 13 على أساس أنكم you don't get confused. هو أساسا meeting 9. إذا حسيتوا أنكم تخربطوا في المسميات اعتمدوا الاسم التوبيك اللي حق نفس الميتنج. فالميتنج حقنا اليوم راح يتكلم عن السيتس and المابس. اوكي بسم الله الرحمن الرحيم. So today we will talk about sets and maps. The objectives of this lectures is to understand some concepts that is help us solve some special problem related about having collections of data. When you have an element, usually sometimes when you have more than one element before, we use list, we use array list and so on. Today we will learn about other concepts to deal with a multi-elements. We can call it like this. Either if we would like to have it order or an order, if we would like to make sure that it has no duplications, so that sets have only unique variables and so on. So we'll talk about new things called hash sets, linked sets, tree set. We will talk about collections and maps and so on. So what's motivated having such idea? In general, it's not only this case, what's mentioned here. This is just one use case. So for example, this slide, they said if the airlines have no-fly, or what some people call the block lists names, for tourist peoples based on their history, so they are not supposed to take a flight. So you don't need to set only their name, okay? You need also to put some details information about the names, such as their age, their colors, such and such. So for this reason, they starting to having other types of, let's say, structuring the informations, such as a set or map, that allow us to have more associated information with the key, such as a name in this idea. So let's get in on the body of our presentations or our meeting today. We will talk about something called collection framework. Okay. So there's no picture. Everyone doesn't have the slides, or just Abdel Manan? Do you have the slides, guys? Okay, good. You remember before the collections as a keyword. This is not the first time we hear this keyword. Can anyone remind me, when do we hear about collections? I'm talking about collections, not a collection. Where did we saw collections before? Okay, so array list. You remember which meeting in the library? It's a class. Okay, so I'll remind you where we saw it, and then we will back to our meeting, because I need you really to distinguish between them. Okay, so you don't get confused with the difference between collections class and collection framework. Okay, so let me show you where did we saw it before. So we saw it before during meeting 4, and this is slide 32. So we saw collections class, which is coming with the utilities package, okay? So in the collections class, it has a certain methods that we used it before. So we put collections, the name of the class, and then we used a couple of methods such as reserve, sort, and so on. And inside it, you can put any collection such as a list here, okay? So you are remembering this part. So let's get back to what we are talking about today. So today we are talking about collection framework, which is different than a collections class that we already explained during meeting 4, okay? So collection framework collections framework, it has two interfaces. So you remember before, when we talk about the classes, we said the root of all classes was what? Remember, what's the root of all classes? Classes. I'm talking about the classes in Java. What's the root? Good. The object class. Now we are talking about the interfaces. So the library, Java library, can have classes and can have interfaces. And we already explained what's the interface. Interface, let's just review it quickly. So the interface is similar to classes, but it has only final variables, whereas the static final variables. And about the method, it only has abstract method, which is mean you have to override it if you would like to use it. Okay, if you remember interfaces, can we create an instance object from interfaces? Can we create an instance object from interfaces? No, that's right. Why? Why we cannot create an instance object from interfaces? No, not because it's final. Yes, it has abstract method, but this is not the reason. The abstract class, it has abstract class methods, but this is not, sorry, the interfaces has abstract method, but this is not the reason. Because it doesn't have a constructor. To create any instance object, it has to have a constructor. So the interfaces similar to the abstract class, both of them, doesn't have a constructors. So that means you cannot create a new object from it, right? Okay? Okay, so let's back to our topic here. Now, since the collections, we said that the object is the root of the classes. Now we have the collections will map are the two root interfaces. So I need you now to remember the collection and map are interfaces. So we cannot create an instance object from them. Good? So far so good. Then we have a set, list, and queue are sub interfaces from who? From the collections. We have two interfaces. They are different here, collection and map. Those three sets, the list and the queue, are sub from collection. So now, I ask you, can I create an instance object from set? Can I create an instance object from set? And why? Okay, no, we cannot create it. Why? We cannot create an instance object. Why? Your answer is right. Because it's no, Bushra, no, this is not the reason. We cannot create an instance object from a set because a set is what? An interface, right? Which is a sub-interface from a collection. Both of them are interfaces. And we just said minutes ago, we cannot create an instance from an interface because an interface doesn't have a constructor. Okay? Similar with a list and a queue. Okay. An array are not a part of a collection. You need to remember this because we're going to use it later. Okay? So list will set, will list, will queue are, remember, are sub interfaces, but not the array. Okay? So you need to try to remember this very carefully. Like, we will go over it and extend it. Like, this is the simple one. Later we will see more details, and we will get sub of it every time we're talking about specific information in this graph. So as I said, we have two root interfaces, which are collection and map. Under collection, we have a set, a list, and the queue, and under map, we have a sorted map. This is more details graph. So we see here, now we just focus on the collection. We are not focusing on a map, we focus on a collection. So under a collection, you will see there are some interfaces. So I need you just to really remember what are the difference between those. So we have interfaces. So all those are interfaces on this side. We have abstract classes and we have concurrent classes. If you remember interfaces, we cannot create an instance from it. The abstract classes, can we create an instance from those classes here? From all those, you don't know what they are yet, but anything are abstract classes, we cannot create an instance from it as well because the abstract class, similar to the interface, it doesn't have a constructor. Okay? So if we would like to create any instance object, we have to use what? A concurrent class. So neither an interfaces or abstract classes cannot help us create a new instance. But we can use them as a reference name. If you remember from the previous class when we're doing revisions, one of, let's say, questions that get you a little confused when we're having a reference name different than the object type. Do you remember that questions? If you're having, you're creating a parent, then equal to a new child. This is what we're going to use it today, and it has the similar idea. Okay? So I just tried to put usual definitions here for you guys to make you understand as we go through this meeting today. So when you would like to declare an interfaces as what we see soon, first you have to have an interface type. An interface type, the blue one here, it could be, for example, collection, it could be set, it could be list, it could be a queue, it could be any interface. So this could be anything here. An interface type. Then you're supposed to put E, which is a type. Okay. Sorry, what's your question? So we can use an interface, abstract as a reference name of the instance. You are right, Yazid. So it's a reference, or in our meeting today, since we are talking about interfaces, we call it an interface type here. Then an E, it is going to be a type of the data. A name object is the name of the reference. No, Batal. E is the type of the data. You will see the example soon. Okay, such as string, integer, and so on. A name object is the name of the object. Then we have a new. Now, a constructor. So an interfaces is going to be one of those classes here. A constructor is going to be one of the classes here in the concurrent classes. So you cannot have a constructor from an interface, but you can have an interfaces type, and then an interfaces type, it could be one of the concurrent class. Okay, so this could go here or here as well into interfaces type. As it's a child, which is main, it's going to already include everything inside the parent. Okay, we'll see more details or more examples about it. So a collection interface is a root interfaces for manipulating a collection object. So as we just said, a collection is going to be the superclass for, or super interfaces for a set, a list, and a queue. A collection actually can have three things, as they explained here. It is going to specify a set of collection interface. So you can have set, you can have list, you can have a queue. So one of its sub interfaces. Based on a sub interface, so if you specified an interface to be set, for example, it's going to help you recommend a constructor. How can we do this? If you go to set, you see which classes, which concurrent classes are associated or implement, which of them implement a set. So it's going to recommend you which one going to go as a constructor here. Okay? So this is what it does it mean here in the second part. Provide some utilities classes. As you know, before any class or any interfaces, it's come with a set of methods that you can use it later during developing your code. Okay. Okay. So an interface, what's the difference between them? You already know that, but let's review it very quickly. So an interface is essential list method without any actual implementation. So for that reason, and in addition to not having any constructor, we cannot create an instance from it. However, in concurrent classes, which is we see it on the side of the graph we just saw, it has an implementation, but it must override any methods already available inside the interfaces if it implements that interface. Okay, what do you mean about implements? Such as when we say a child and parent class, we said inherit, إنه هو راح يرثه. When we said implement الانترفيس, خلينا نقول مثلا هذا الكلاس هو راح يستخدم الانترفيس أو هو راح يعمل مناداة أو uses any interface there. So it's the keyword is implementing that interface. So if any classes implement a specific interface, that means it's going to use, but it has to override any method that exists in that interface. Okay. So the collection interface, as we said, is a super interface for a list with set and the queue. All the methods are inherited by interfaces. Since they are inherit, let's say implement, inherit, because from interface to interface, we said inherit. But from a class to interface, we said, what is the keyword? Implement. Okay? So since a set, a list, and the queue are interfaces, with collection are interfaces, so we said inherited file interfaces. A collection interface specified methods. So a collection is going to have add size is empty, which is mean the sub interfaces, a set with list to the queue, are they also going to have those classes? Okay. And to use a collection interface, you have to import Java data utilities. Okay. Now here, they list some of useful information or useful methods inside a collection. You see here, this is the collection, and they mention its interface. So let's focus on this part first, and then I'll explain the two other boxes in top and bottom. So the first method is add, which is being if this method gets one argument with a type E, which is a generic, could be a string, could be an integer, and so on, and is going to return Boolean. This is going to add any element with a specific type, and if it's added correctly, it is going to return true. If it's not added correctly, it's going to return false. Add all, it is going to get a collection, so it's not going to get only one element, it's going to get collections. This collections, it could be set, it could be a list, it could be queue. So it's any type of collections. And it's going to return true if it's added correctly, false if it's not, a clear, it's going to remove everything and it's return nothing. Contains, you send a specific object, okay? This object, it could be primitives, or it's just, it is only, or it's going to be referenced as we have it here as an object. So if it's find this object inside this collection, is going to return true. If it's not, it's going to return false. Contains all, that means you're going to send a set or list or queue, any collections, any collection with a set of elements, and if those are added correctly, it's going to return true. If it's not, it's going to add false, return false. Equal, we know this one. You get it to return true if they are equal to the one that invoked the equals method. The hash code, it's going to deal with creating hash. We will see more. We'll talk about it more soon. It is empty if it's empty or not. Remove a specific object. Remove all this collection. Return all. What does that mean? This means the one or the collection or the elements that it's invoked retain all have, it's going to return the things is in the intersection between those elements and the one here. Okay, so it's going to return both. The one it is called invoked methods, and the one is sent here. We'll see an example of it soon. So just remember it, and this is to return size, to array, to cascading to string. Okay. So now we'll talk about the above and the bottom box here. You see, it is two interfaces. The first one on the top here, it's called iterable. And the one on bottom, it's called iterator. So a collection interface inherits an iterable. So, and its iterator is inherits an iterable as well. So that means any collection here can use the method iterator. Okay? So what does this do? It is return an element for return an iterator for elements in this collection. So it's going to go over those elements one by one. Now we will see how we can use the iterator. You remember the array list. It is something we already talked about it before, and hopefully you remember it, okay? So first we're gonna to create, first we're gonna to declare. So here we just declare. So we declare array list with a name list1. Then we create, so this is the second part. We create an array list with a type string. So this is E, the 10. You remember when you ask about the E? So this is the E here. Now we use it as a string. Sometimes it's going to be integer or so on. After we said we declare. You remember, I need you to remember the difference between declare, create, and then we initialized. Declare, create, initialized. So first we just declare. This is the first part here in the red. Let me change the color. So let's see if we're using the green. So here we create, and the third things on, let's say, purple, this is the initialized. Okay. So then we initialize it, we add elements on that list, okay? How we can print array list? There is different way. If you remember from the slide, the first way, which is the easiest way is just using the print line. The second way is using loop, starting from I0 and until the size, and then you call a method get, and then it is going to print them one by one. And the third way to do it is using for each. So for each string, why we use a string here? Because the contents of this array, the data type inside this array is a string. Okay, so that's why we create a temporary place called X with a type string. We go over list. It is going to go over the first place, which has malak. So it's going to put malak here, and it's going to print it out. It is going to go again. It's going to ask, what's the next element? It's going to say Lulu. So it's going to put Lulu here. And it's going to, where Lulu is X here. It is going to print it out. It's going to go over it until the end of the list. Okay, so this is for each. So now, an iterator interface. You remember iterator interface? We just saw it in the graph. An interface allows traversing, iterating through any collections. So, such as an array list, a set, which is we're going to see it soon. So it's help us go over those collections. The following abstract method. So we have an abstract method that we can use. They already defined inside the iterator interface. Okay, and a set will array list and so on. They already implement their classes, but the set here is going to inherit from an iterator. Why? Because the set inherits the collection. The collection inherits the iterators. So as a result, a set is going to inherit all the methods inside the iterator. Good? So what are those methods? We already saw them before. We have has next, So return true if the iterator has more elements. So instead of saying for loop, we can say a name of the collection, the attributes, or the instance. Dot has next. Whenever it has next, it's going to return true. So we still have some elements. We're going to print it out. We can use a next. In this case, is going to return a next element. This is going to return true or false, which is going to return. Let me use another different because it's already purple. Okay, so it's going to return Boolean, true or false. But the next is going to return E, depending on your type. So if it's a string, it's going to return string, integer, double, whatever you have there. So this is what it's going to return. They explain it here as the type. The third method is remove. It's not going to return anything. It's just going to remove from an underlining collection the last element. So what it's going to do, remove the last element returned by the iterator. Not that important to proceed any call for remove by calling the next. What does that mean? This is an important sentence here. This is mean you have to use a next if you would like to keep removing, because if you remove one, it's at the end. You have to do next, and the pointer will be on the next, and then you can remove the one before it, and so on and so forth. Okay? So you have to have a next if you would like to use a remove. Okay. Iterator interface. We will now learn how we can declare a variable to use interfaces, iterator. Any class that implements the iterator interface may be referred by such variable. So we having now, this is the first line here is an array. And then it's called the X. Then we add two elements. This is from previous example, nothing new. This is the traditional or the one that we used before. So let's assume now we would like to use the iterator. You see here, I said iterator, string, list X. So the variable is list X. Then I said X, this is the X here. So the X here is this X, okay? We are not talking, don't get confused. This is the list X. So a list X, it could be, have an interfaces type iterator. But you remember, we said before, you cannot create an instance object from it. So when we call here X dot iterator, we talk about this X. And this X here has array list type. It's not an iterator. Okay, so now why it's be able to invoke a method which is inside or it's coming from an iterator. While X with a type array list, right? But it's still be able to access a method that is coming from an iterator here. Why it could do this? Why we can do this? Do you remember the example from a review? No, we don't do casting here. An iterator is a method coming from an iterator interface. But since we already having it as the references here, no, not because it's extended. Since we have it as references or interfaces type here, you can access its methods. I don't know if you remember a revision when we're having a parent with child, you can access the methods from this one, okay? From an iterator. No, not because it's static. Because it's the list X, the interfaces is iterator. So you can access its methods. Okay. Again now, has X or list X can access it has next. It has next is coming from an iterator interface. So you still can access it here. Okay. So you will go over the list one by one and make sure go over it one by one, and then it is gonna to print next. So as long as list X has next, it is going to print next here. So here are some collection interface. Now we will back to collection. Previously we was talking about the iterator. Now we back to a collection interface, which is the root interface for a set, a list, or a queue. صحيح? So that means, as it's the super interface for a set, or list, or a queue, that means all those methods already available also inside the set. So you can add an element, you can add a collection of elements, you can remove one element, you can clear the collection, get the size of the collections, make sure, or if you would like to test if this collection has a certain object or not. So you send a specific object and it is going to return true if it's available on the collection and false otherwise. And it's empty if it has an element or not. So now we will move to set. Do you remember set is the sub interface for which interface? The set interface is the child, it's the subclass. Oh, sorry, it's the sub interface for which interface? Do you remember? Okay. Any other thoughts? Collections. You're right, guys. So set is the sub interface from a collection, which is mean all the method we just listed, it's already available inside a sub interface, which is a set. So now, what is a set and what's make it different? A set, it has not order collection. This is the first properties of set. It has no order collection. In addition to that, it has no duplication. So it has a unique value. So this is the first properties. It has no order usually, but we will see other ways to or sub classes that can be ordered. But in general, it's not ordered, has no duplication. Three, what's make it different also, it can grow and shrink, which is meaning you can add and remove from it, or we can, which is called dynamic size. Okay, and the fourth properties is not indexed. What does that mean? During our study, we learn about a list, the array list, how we can access, for example, the first element on a list. Can anyone remind me? How can I access the first elements in the list? What about an array list? So this is how we can access the first element in the list. What about the array list? No, not add. Add is given to add. Yes, get. Okay. So you put get, and then you put inside it, you missed something, Rizam. Can you complete your sentence? So, get what? If I said specific index, what I mean about الindex is 0. في المثال اللي انتوا كتبتوه هنا index 0 في list, you mean the first element. Index 0. But what about the array list? If you would like to access the first element, which is the first index 0. Index 0, get what? Sarah Wissam, you're right, get, but get what? Completed. Get. No. No Bushra, no Abdul Manam. Can anyone remember how we can get? You almost there, Lujan. Change the type of parentheses, الأقواس. إيش نوعية الأقواس لجان؟ Square or half circle? Good, Abdul Manam. Okay, you get it. So you remember now. For list, array list, you can specify. I'm gonna to give that specific index 0, 10, 5. However, in a set, you cannot do this. Okay? It doesn't have an index. So we have no way to reaching a particular element. You cannot set a particular element, I'm gonna to access it in such place. Okay? So this is a general thought. Later they said there is a way to have an order set. Sorry, so we can have an order set, but generally it's not an order. You should think of a set as a pool of objects. So you have a pool of objects together, and order uniquely, but you cannot access it. Okay. Let's get more information about it. So we saw the 4 main properties: no order, no duplication, cannot access specific index, and the 4th one was it's dynamic sizing. Okay, so a set of interface extend the collection interface. So that means it inherits its method. It doesn't introduce a new method or constructor, but it stabilizes. So it's not going to have a new methods, but it's going to make it more specific and give it more detail about the set. To have it not duplicated elements. The concurrent class that implements sets must ensure that no duplication elements can be added to them. What do you mean about this? What are the concrete classes that implement set? What do you mean about this sentence? So let's highlight it. Concurrent set that implement concurrent class that implement set. If we back to this slide, so here's a set. The concurrent classes here that implement a set. So any concurrent class implement a set, it is going to have, okay. Must ensure no duplication. So all those classes that implement a set, make sure they having no duplication. There is no two elements, E1 and E2 can be set as an equal. If you remember, equal methods is going to return true if E2 equal to E1. And this is never ever going to happen in a set. Why? Because a set has a probability that it has no duplication. So all the elements inside the set is going to be unique. So it will never ever going to have true as a return for equal methods. So here is a hierarchical for set interfaces. It is important to remember the hierarchical of the interfaces and the classes in general, so you know which method can be accessed or not. So we having an interfaces collection, which is the root, and then we having a set interfaces inherits a collection. We having then what's important for us here is a hash set as a concurrent class, so it's not an interface. It is going to implement a set. A link hash set is going to inherit a hash set, which is implement the interface. And here, which is important for us to literally set. So those are the three concurrent classes that we are going to study today. Okay, can I create, so I told you now, those is what we're going to study. Can I create an instance object from a hash set, a linked hash set, or a tree set? Can I create an instance object from those classes? And why? And why, Eugene? Exactly, because they have a constructor. Let's highlight the constructor here. Okay, so this is the constructor. Here is the constructor, and this is the constructor for this class as well. So we can create an instance object from a hash set, a linked hash set, a tree set, because they have a constructor. But can we create an instance of object from a set? No, because we cannot create an instance object from a set or a collection because they don't have a constructor. They are interfaces. Okay? So now, an interface type it is going to be one of those, for example, a set or a collection. So I can say set and get it to be an E generics string integer, a name of an object, XYZ, whatever name, and then the constructors, which is going to be green in our case here, a constructor, any classes that have a constructor. So we're going to call one of those constructors here. So those are the green and the interfaces on the top. Okay? So how we can create a set? They said creating a set. We just said we cannot create an instance. So what they mean here about creating a set, whenever we use any kind of collection from a Java collection framework, there are three things to remember. We need to decide, choose, declare. Decide what? Decide, we need to decide an interface type, which is, we remember we had it as a blue. An interface type, the first one, decide. An interface type, the protocol you want to use with our collection. An example, an interface set. The second things, So let's pointing. So this is number 1, 2, 3. So this is the first step. The second step choose an implementation class. Implementation, what do you mean about implementation? The class gonna to create an instance. Okay? Implementation, the creation, not only deciding or just initial, we're going to create it, not only declare it. So this is going to declare it. Here we're going to create it. We're going to implementing. For example, the actual will be actually collection belong to, such as the hash tree. So this is the second part. Okay. So second here, and the first is choosing an interface. The third step to decide, you need to declare an element type. An element type, so this is the one here. This is number 3. An element type, you need to ask yourself, am I going to deal with a string, or I'm going to deal with integer, or I'm going to deal with a double? So depending on that, you're going to define the element type. This element type could be a reference, should be reference, not primitive. What does that mean? Can you give me an example of a primitive type, data type, that I cannot put it inside instead of an E? Int, you're right. So instead of an E, I cannot say int. This is wrong. Why? Because it's a primitive. Instead of that, what can I use instead of int? If I'm going to deal with integer, what I'm going to put instead of an int? Yes, we're going to use a worker class, you're right, as they said here. And what's the worker class for int? Integer. You're right. So here we will have an integer. So you can have only a reference type, you cannot have a primitive type. Clear? Okay, so now we will learn more about a concurrent class, which is we can create an instance from it. Okay, which are they? As I said, I highlight them on the graph. So we're going to talk about the hash set, the tree set, with length hash set. Okay. So if we would like to create any set, you cannot set equal to new set, because the set is interfaces. So we need to get help from the concurrent classes. The concurrent classes related to hash set we're going to study today. The hash set, the tree set with length hash set. What's the difference between them? The hash set, it doesn't maintain any kind of order, so it's an order and it's unique. So two things, an order and unique. However, the tree set is sorted ascending, in ascending order, and it's unique. A linked hash set, so a hash set and order. A linked hash set, it is going to maintain an order as you insert it. So if you insert 153, it is going to stay 153. However, in a hash set is not always this is the case. It's going to be unordered. Okay? So you need to remember all of them are unique. What they are different in hash set and order. The tree set ascending order will link hash set insertion order. It's going to remain in insertion order. So whatever you enter there is going to remain as what you inserted. Okay? So this is clarify for you how we can declare and create. I just talk with you about it, but here they put it on a picture again. And I cannot emphasize more. This is very important to differentiate it between a declaration and creation, with initialization later. Okay? So declaring and creating a variable to reference a set for holding string. It is going to hold string. This is main. E is string here. Okay? So we having the class object to new constructor, so we call constructor. So this is in general. What we have it today, you have an interface or interface type here. It is going to in this example is going to be set, and then we're going to have an element type, which is an E. In this example, is string. Then we have a variable identifier. Whatever you put the name, it's hard set in this example. So this part called declaration. The other part here equal to new, or we just put it in a new line. This part is a creation. So we put a keyword new, and then we construct for a hash set. We call it constructor. Okay, and then we need also again to define an element type, which is string. Okay, let's see some examples about declaring and creating. I'm missing I here. Okay, sets collection. So collections interface, and then an E, a name, the new, and then constructors. This is template definition for declaring and creations. So here first, we declare variable set1 with the interface set and the element type string. Then we call the constructor hash set to create the object. This is similar to have it here, or you can use it in an interface and the constructor similarly. They give you an option that you can decide or initialize the capacity at the beginning. So in this case, we having set double, and then in constructor's hash set. And also it's give you another option to initialize it with other collection. So we having a set1. Let's assume we already initialize it. We put some elements inside it. Then we can just assign its elements or add its element, all of its elements inside set3 in this example. Okay. So let's see this example. If I create set4 and then I create, I declare set4 and I create it as a tree set, which is gonna to get a set from L1. How set4 is different than a set1? What's the difference between a set4 and a set1? You don't know what's the content in general. Now we define the set1 as a hash set. I need you to remember the probabilities of a hash set and list tree set. What's the difference between a hash set and list tree set? So then you will know what's the difference between a set1 and a set4. So set1 is coming from a hash set. Set4 is with a type tree set. So set4 is okay. I see one right answer, but let me see if any other students would like to share their thoughts. Okay, so Yazid, no, sit1 is not inherited from sit4. We add a sit1 content inside a sit4. But the sit4 as going to be order ascending. It's have ascending order. What about now? Can you hear me now? Okay, can you hear me now? Okay, good. Yes, so it's going to be ordered and unique. So let's go ahead. So the hash set class, what is its type? Is concurrent class that implements a set. For efficiency, object add a hash set need to implement a hash code method in a manner that properly disposes the class. This is what's mean in general. الهاش code usually موجودة هي الهاش code methods inside الهاش set, and it's helped بالجافا virtual machine find the data that may be anywhere in a large block memory. So الميثود الهاش كود هي ضمنيا هي موجودة بالهاش set, so it's going to help find the elements, okay? But we are not going to call it or invoke it to do something actually. So here they just tell us how we can declare. Okay, Muhammad, you can email me later. I cannot answer here. So with hash set, either you said hash set and then you put E, or you defined, as we saw before, you put certain collection, okay? The other things we're going to talk about is a sorted set. To do sorted set, we get to use the class the tree set, okay? A sorted set is sub-interfaces from a set, which is guaranteed that the elements are set sorted ascending in ascending order, and then to do this, we get to use the tree set, and this is how we can do it. Tree set and then an E, or you can send a certain collection, okay? A linked hash set, if you remember, it has one difference between it and between a hash set. A hash set and order. However, a linked list is going to be insertion order. So whatever order you enter the elements on it, it's going to remain as it is. A definition or a creation is going to be similar to a hash set, a tree set. Okay. And here are some methods that is available inside the set. And they're similar to collection. So size to return a size, add a specific element, test if it's empty or not, send a specific object to see if it contains inside that set or not, send certain object to remove it from a set. Okay. Sorry, where we are here. So now how we can iterating over a set, how we can go over it one by one. Either we can use the for each statement or we can use the iterator. For each statement, you know it, guys, right? So this is supposed to be not that hard for you. So first, in this example, we declare a set, okay. So we declare a set created as a hash set and an element type string. Good. Later, we invoked the add method into that to add London, Paris, and so on. After this, how we can print all the elements inside the set. Do you remember with the array list? The array list, to print the contents of it, either you use a loop, or you can, in the example we just saw it slide ago, when I wrote 3 ways to do it, 1, 2, 3. Either use the print line, a loop, or a for each. Similarly here, you can use the print line to print a set. Okay, so you can use only print and then put a set, and it's going to print the content of a set. This is the first way. The second way is to use it for each. So why we put string here? Can anyone tell me why I have a string here? Why not an integer? Type of what, Lorraine? Why we have string? So we'll go over a set one by one. What is it? Because they are string. What is the string? Exactly, Abdulmanam. Elements are string. So element type, if we connected, so this is because of this. So set, the content is going to be string. So temporary spot is going to be string. We'll go over it one by one. So first, we will get London and we will put it here on the S and then print it out. But you remember, during doing the tracing, if you have an example, you need to make sure you read carefully what they're asking you to do. So your answer, Abdulmanam, is wrong. So what they ask you to do? S dot to uppercase. So what's the output here? So what's the output for the first element? London as capital. So you need to be careful, guys. If they put just S, it is going to be different than S to uppercase. It's going to be different S to lowercase. Okay? After finishing the for each loop here, we're going to print out a size. How we can print out the size? We put, So we put a name and invoke the size method. So what's the output here, guys? What is the output of the last line? I'm not going to talk about other things. What is the output of the last line? Okay, as I expected. Okay, some of you said 5, some said 6. Can you clarify why you said 5 for those who said 5 or 6? Unique contents, that's right. So why are we having 5? Because the last line here didn't add it. We not added New York because we already added at the beginning. So the length will be 5. 1, 2, 3, 4, 5. We don't add the last one. You need to be careful, guys. A set, a hash set, a link hash set, a tree set, all of them has unique elements. So even without they telling you here. You need to remember that, okay? So let me just declare. So this is the final output here. Yes, لجين يعني ما يكرر exactly. المكرر تحذفيه no لجين at the beginning أصلا ما راح تضيفيه. يعني هو لما الكونسبت اللي حق الست انت تسألي هل المكرر نحذفه؟ الفكرة اللي حق الست ان المحتويات اللي حقها راح تكون يونيك. اوكي؟ سو متى ما اضفتي قيمة راح يشيك عليها هل هي موجودة او لا بداية قبل الإضافة. لو كانت موجودة من الأساس ما راح يضيفها. Good. So let's say it again in English. Okay. So if you would like to add any new elements, first it's gonna to check. Is this element already exist? If it's yes, it's not going to be added in the first place. Not added and then remove it. It's not going to be added in the first place. Okay? I cannot answer this question, Yazid. Okay, so here it is going to be the first line. Okay? And this line, this and this together is going to be the second line. Okay? Okay, you get it? So if you just use print, you need to remember two things. First, it is going to print square practice, and it's going to write it exactly as you add it. No upper, no lower, nothing. However, if you add it as two upper, and here you're using the print to print them one by one, and you remember here we're using the print, not print line, so it's not going to be a new line. So you put it, the first one, the second one, and you're just leaving some space. Okay? So you need to be careful how an output is going to be look like by carefully reading the code. Okay? Isam, I just answered the question. What is happen if the iterator through the set and check if the content is previously added? It is not going to add it. Like in our example, you see in New York, it's already added before, so it's not going to be added in the first place. Okay, so let's see this exercise. Exercise 1. I'll tell you guys now how you answer an exercise correctly. I need you to learn how to analyze the question so you can answer it. Good? So to do so, I need you to remember 3 steps. Declaration, choosing the implementation, decide, choose, with declare. And then I need you to remember how you write it down so you can remember how to do it first. So let's deal with the question. Create a set. They already told you it's a set. So an interface type is going to be set. So an interface here, you put it as a set. Okay? So you can go over it like this if you have an exercise. Then they said of what? Of string. Try to remember this is always. So put it one by one. So instead of an interface, we will have set. Then instead of an E, we will have a string. With each element being the name of herb. You can call it whatever, a name of object. Okay? Being the name of an element of herb, let me just check something. Okay, yes, in the name of it, it's already called hash set. Okay, so can I just call it set, and then herb set is the name of a variable, new set string. What do you think, guys, about this one? It is complete, it is correct, it is missing something. So, as I told you, I needed to learn how to analyze the exercise and try to answer it correctly. Okay, set string herb, new constructor. You need to put something instead of constructor. Abdelmanem. We put set. Is this correct or not? This sentence is correct or not? Exactly. So this sentence is incorrect. This sentence is incorrect. We cannot use a set for an implementation class. Set is not, doesn't have implementation class. Okay, so instead of that, I already saw a right answer here. Good, Lujan. But before that, before you put your answer, I know maybe some students just get confused. How we can choose the implementation class? I need you to remember this. Within step 2, read the question carefully and see if they give you a hint what's the correct implementation class. For example, if they told you the set's supposed to be having ascending order, so you know you're supposed to use tree set. If they tell you the set's supposed to stay in insertion order, so you know you're supposed to use the linked list. Are they giving you any hint here to help you choosing among those three? So the implementation class is going to be one of those three. Are they giving you any hints in this exercise telling you how to choose which implementation class you should choose? Can anyone figure it out if there's any hints? So you can choose, should I use a hash set, a tree set, a linked hash set? Okay, since they didn't mention what it has a sorting order or insertion order, usually it's not going to be an order at all, so it is going to be hash set because they didn't mention it, okay? So it's going to be set string Harper set equal to new hash set. Okay. Then how we can add the following harp. Roseberry, for example, we're gonna to put a name of a variable harp set, invoked an add method that add, and then we put them one by one. How we can print out the size, we're gonna to invoke a size method, put a name of a variable that is size, and it's going to give us a size. And the final thing, when they ask you to print a set, they get it to be either be in general requirements, such as this one. They said print the set. They didn't ask you to use a specific method. Do you remember for printing? We said either you can use print for each, or you can use a loop, for example, an array list if it's an array list, okay? They didn't tell you which one, so it's up to you at the end. So we can just use the print as what we have it here in the exercise. So first, we declare, create a variable. We initialize it by adding some elements. We print a size by invoking size method, and finally we print it out up to us which methods we use because they didn't specify it. So the simplest, easiest way to print a set is using system.out print. Okay. This is going to be the output. So size is going to be 3. Why? Again, because the last one is not going to be added. So 1, 2, 3. And it's going to print it in this way. If you're using a print line, it is going to print it in this way. You're having the practices and then comma between each element, and they're going to be in the same letters, either small or capitals. The tree set class, it is going to be, what's the difference between it and the hash? It is going to order ascendingly, which is going to be alphabetically for the alphabet. For a number, is going to be a 1, 2, 3, 4, and so on. How we can define it? In the previous one, we have hash set. To have it in alphabetical order, we just going to change it to tree set. So in this previous one, if we would like to have it in order, we just going to change this part here to have it a tree set. As I said, if you use a tree set, it's automatically going to be order. Counting the keyword. This example, you're going to count unique keywords. What's the difference between an array and a set? We said it, Omar, at the beginning. الأربع الخصائص اللي حق الset. What it is? It's unique. Array, it's not unique. It has a dynamic size. This doesn't have a dynamic size. In order, array, it's depending on how you put it in, and then you index it. Array, you can figure it out. You can go specific index. The set, you cannot do this. Okay. Counting keywords. Okay. This example you can do at home, unless we have a time at the end. I'll do it for you guys. الidea اللي حقها الفكرة حقها, you will access the file. You have a file, and then you will check it out. You have a set of keywords, and then you would like to count how many times those keywords are repeated in a set. How you can see the code? Just try to click on this green box and you will see the code. If we have a time at the end, we will back to it, okay? Okay, so now we'll see some, let's say, important operations that you could use it with a set. The first one contains all. This is going to return true if the set2 has all the elements inside set1. This doesn't mean they are equal. That means set2, all the elements inside the set2. That's true if set1 contains all the elements in set2. So set1 have all the elements in set2 and not the opposite things. Okay. The second method, add all. You put to set2, and then it is going to return. So this is going to modify the set. This one, it is going to not to put the whole information here. It is going to put it except what? The one that's not already there. So for example, لو كان عندنا 1, 2, 3 in a set 1 and 2, 3, 4 in a set 2. So we will add only 4 in 1. So we'll add all is a union with a just unique. You are not going to repeat it again. So this is a union. I'll add all. A return all, it is going to be intersection. So it's going to return the common elements between a set 2 and a set 1. if it's already exists on both of them. The fourth element or fourth method is removed all. It's like subtractions. So if there is any in common between S1 and S2. If you don't get it, don't worry, we will see an example now, okay? For all of those methods. Operations could be one of the type, one of the type, destructive or non-destructive. Destructive element or operation اللي راح تعمل it's going to do some change, iterate في ال content. If it's going to do any change في ال contents is destructive. Non-destructive مثل ال operations اللي يكون فيها testing. It is empty, it is has next, or so on. Those are non-destructive operation. Okay? So let's see here. Just as a reminder, return all is going to be intersection. Add all union, remove all set a different. So this is the exercise. It's going to have information. We just saw it. But first, they're using new things or a concept we haven't touch it during this meeting yet, so just try to focus with me, okay? So first here, they tell you to create a new linked hash set. They give you the first one and the second one. But now, they enforce you to use an array list. You cannot use create linked lists, linked hashed, for example, S1 and then said S1.add 3, S1.add 4, and so on. No, they ask you to create an array. Then we will read the rest. Now I need you to focus on this line about array. How we can do this? First you create, as they ask you to create an array, we will focus on the first one, okay? So this is the first array. So you create, first you declare an array A1 with a type integer. And it's important to use integer, not int, okay? Because we will then get it to casting it or change it to as a list. And we put equal, we put the content. So far, we have a list called A. Then we're going to create a list. This is an array list, an array. Then we're going to declare a list called L1 to put the content of the array. We use arrays.asList. So you're going to convert the elements اللي موجودة بالA1 and put it inside L1 here, A1, sorry, from A1 to L1. So L1 is a list. A list is implement or inherit collection. فهي الtype حقها collection. So then we can use it inside a linked hash. Let's see it in the example. So this is the steps that I told you to analyze any questions. And then we decide what we get to use. So they already told us to use a linked hash. So we're going to use the linked hash here, okay? Then they find and print their union, intersection, and a difference between them as methods we just saw it. So let's see the example. The first part is dealing with when they asking you to use an array and then you put it inside a linked or a set, a linked hash, a tree set, hash set, whatever. Remember this step. So we having the array. Good. Then you would like to convert it to list. How we can convert any array to list? We use the arrays. The name of a class arrays. It has a method called asList, which is gonna convert the A1 into an array list. Sorry, it's going to convert it to a list because it's going to we're using an array list to use an array list because the array list is a method from arrays. That's why we're using an array list as an object type. But then it's going to convert it to a list. We do the same thing with a second array. Why we do this? Because when we're creating a set, for example, set one here, with object or constructor linked hash or tree set or whatever, and you decide what's the element type, what's important for us is here. It's receive as an argument only element with a type has collections. So an array list or an array are not with a type collection. That's what they said at the beginning. If you remember, maybe in the third slide or so. That's why they told you an array list is not with a collection. A list is. So we convert them to list. So then we can put them inside as an argument. So their content, one by one element is going to be added into a list S1. You get this point, guys? Question? Should I repeat it again? Or is it clear? Okay. Now they ask you to use an array. You create an array. Okay. Yes, Abdulmanam, suppose I to repeat it again, or it's clear? Okay, thank you. So as it's clear, we will move. Now we're having S1 or S2 as a set, and they are linked hash set, which is mean they remain in an order they are inserted. Good. Now we need to find the union, an intersection with difference. We create a new variable called union. Interface is type set, but the constructor we used a linked hash set because we don't need to change the order in this case. And they told us at the beginning already. And then S1. So the content it's inside the union now. What is inside the union? S1. What's inside the intersection? S1. What's inside the difference? S1. What are we going to do later? First, we're going to print S1 plus S1. So what is the output? It is going to print S1 in the same order, 3, 4, 5, 2, 1. Then we're going to print S2 and it's going to be in the same order. So it's going to be 2, 3, 7, 8, 9. To figure it out the difference, which method we're going to use? Remove all. What's the output of this one? If I print it out, system.print S1 minus S2. What is the output of this sentence? What's the output of this sentence? Okay. None of you get it. Let's make clear. Okay. So what do you mean about the difference when you said the minus? That means what's the elements are on A but not in A2. 4, 5, and 1 because the 3 already there and 2 is already there. No, you don't delete the duplication. The difference mean, right, it's gonna to return an element that's already in A1 but not in A2. So 4, 5, 1, they are in A1 but not in A2. So this is what minus mean. When you said minus, you get to remove, delete any elements already exist in an A2. Okay? The second one, it'll add all union. What's the output of the union? It is going to get all the elements but without any duplication. So it's going to get 3, 4, 5, 2, 1, 7, 8, 9, which is all the elements, but it didn't said 2, 2, 3, 3, 2 times. Okay? I'll do it faster so we can complete the lesson, okay? Due the time. I'm not going to give you some time to tell me the answer. The last one is a return all that is going to do an intersection. So what's the intersection between them? It is going to be 3 and 2. So it's, both of them has those elements. One more thing here, guys. You see those 4 sentences? You can write them in 2 sentences instead of 4. How can you do this? For example, if I take the first one and the third, this and this, you can put them together and write them here. So from the beginning, you said set integer S1 new, then cache set, and then you convert the A1 directly. You don't need to create L1 and L2. So you're just wasting the memory. Doing this way, it is just wasting the memory, creating an extra variable that there is no really need for them. Okay. So this is one way to avoid an extra element. Now we will move to the map interface. The map interface فكرتها is that you're going to have a pair. And instead of having only one element, you can have a pair, which is we call it the key and the value. The key is not always integer. I know it's maybe sound like it's the key, it's always integer. No. The keys could be integer, double, string. It can be an object, TV, circle, object you create class for it, and so on. So the keys could be anything as also a value. But what makes the keys different? It has to be unique. So how will map? What's the map features? It's a dynamic sizing, similar to set, but how it's different than set, it's indexed. The set, you cannot access any variable directly. You have to have an index. You cannot access it through an index. But here you can use this concept using the key. Third, features is not allow duplication. This is similar to set. And the fourth is similar to set as well, which is an order. So the only difference than a set, you cannot use the index. Here you can index it by using the key. So how it's look like? You having the elements here. So this is whole together, both of them call entry. And what does it contain? It contains a key and corresponding element value. مثال example, so you're having the ID or the phone or whatever, and an associated or the corresponding value and name. Both of them together is called entry. So each entry is going to have both key will value on each element or on each entry. الماب انترفيس الهيراريكال ايش راح يكون فيها الانترفيسز حقها؟ So we having الماب, it could have a sorted map or navigable map. We're not going to talk about them today. We have an abstract class, and then we have a concurrent class. This is what's important for us. Why we need those? To create an instance. You remember, we cannot create an instance from a map because it's interface. So we need to use one of those classes here to create an instance. So those what we're going to cover: the tree map, the hash map, a link hash map, which are similar to a set as well. So how you can put and get information from it, you use the get and the put method. Okay. Here are the main methods for a map, which is having clear, to clear it out, contains entry set and so on. Almost all of those similar to a set. Let's take a look what's different. For example, a key set, return a set. When you use the key set, what is going to return? It is going to return a set of keys, not a value. It is just going to return the keys. Okay. Get, for example, here you send a specific key and it's going to return a value. So this is a key here. Play a role like an index في list وفي array list. Okay. عصام, like a dictionary. What do you mean like a dictionary? No, it's not like a dictionary. It's like having an index في list والarray list. بس الاندكس في الليست والarray list ثابته، راح تكون 0 1 2 3 4 5. بس بالماب الكي ممكن تكون الاسم، ممكن تكون رقم التليفون، ممكن تكون it could be ID, it could be whatever you decided as a key. Okay. And here are some methods for the interface. Size input. This is similar like a previous one, but with more details. Now what's important for us, the concurrent classes. You remember في الست كان عندنا الهاش set, التري set والlink hash set. Okay. Here what is important for us, what's important for us, الhash map, which is going to implement the map, will link hash map, which is going to inherit the hash map and according to this implement the map as well, will it tree map. Okay, this is what we're going to cover. Here what I need you to remember is it is similar to what we have during a set, but it has one difference. During a set we having only one element type, right? Here we having the key type and we have a value type. The key type will value type. Okay. Otherwise we have an interface type, which is going to be map, and then a constructor, it could be tree map, hash map, or link hash map. So those are the three main concurrent class that we're going to use. The hash map, no ordering on the key or value, ما راح يكون فيها order. التري similar، التري map similar to the tree set، ان هي راح تكون معمول لها order but for which؟ for the key not for the value. Okay. اللينك hash map, it's like insertion order for the key again. So it is similar to set exactly, but set, since it has only element, فلما نتكلم عن order we're talking about the element. However, here في الماب, when we talk about the order or not order, we're talking about the key. Good, because it has a key and it has a value. So you need to remember it as this. The hash map, no ordering on the key or the value. The order, the tree by the order, or insertion order by for the key. لكن the hash, it's not going to be ordered either by the key or the value. So this is the example. Similar to array lists and a set, both of them. راح يكون عندنا is going to have both the key and the value. So the key is the red one here, string, while value is the purple one. So we're creating from the map, which is the interface, a variable table1 with the hash map, the key string and the value string as well, or we can have it hash map for the references and also for the declaration. We can have not always string. For example, you can have a string and double in this example, and you can initialize it with a specific capacity. So you define a size at the beginning, or you can use another map. So table1, it's already defined before, it has already key and value, and you get it to assign it to table3 in this example. Okay, and in this one here, we're creating a table4 with a tree map. So what's the difference between this one and the previous one? The tree map here. Yes, it's going to be ordered. You're right. It's going to be an ascending order, actually. So this is how we can write down a declaration and the creation for a map. Okay, what if we would like to traversing the map collection? ايش ممكن نعمل على اساس ان احنا we go over the elements that it has inside the map? Either we go using for each statement to go row by row, which is entry by entry. So each row has an entry, which is an entry is a key and a value, right? So to use it for each, first you need to define the key type. And this time we care about the key type. We call a variable, whatever name, variable XS. Then this is how it's different. We put the name of the map dot the key set. So this is how we let's see the example. This is how we declare it and creating a map, and it has string and string, and its name is table1, right? Then we use the hash map, which is going to be an order to create this map. So far so good. Then we would like to go over it one by one. So we will use it for each. So we put for, and why we put string? Because it is going to be based on the key type, not based on the value, right? Both of them is string, but we're looking for the key type. And then we put any name, key, X, Y, whatever. We're using temporary location. We put a name of a variable table1 dot get set. What does a key set return? It is going to return a set of key. So it's going to return, for example, if you're having a name of student, it is going to return a name of the student. Or let's say, whatever, let's say an ID, but you store it as a string, okay? So it is going to return an ID in this way. But now you would like to print out the key and the value. So you're going to print the key, which is your return. So this is going to go over the key one by one. And then you put a space. And now you would like to get the value. How can we get the value now for that specific key? This is not like a list with array list symbol. You put a name of the list and then between square 0 or 1. Or for example, for the array list, we put get and then index, صح? Here is similar to the array list, but the key, it is going to be the key you have it here, which is can be integer, can be string, can be anything. It's similar to the array list. So the key, you send the key, which is any type, integer, string, whatever, and it's going to return a value for you. Okay? Okay. So now this is the third exercise, how we can use the hash map with the tree map. The hash map, it is going to be give us an order. فمثلا in this example they ask you to add those contents, Smith, Andrew, Lewis, which is have a name as the key, will age as the value. Good. And then they ask you to print out the age, the name, for those who's having the age greater than or equal to 30, print out the age اللي حق لويس. وبعد كده they ask us to use the tree map لأنهم they would like to do it in order. Okay? So let's see quickly the code. So we're creating a map which is called hash map. So this is the variable. We're using a hash map, but remember here this is a small h, not a capital H, because it's key sensitive. So a string will represent a name, an integer will represent the age. Then we get to add an entry. How we can add it? We use method called put. We don't use add. We use put for a map. So we put them one by one. So we add 1, 2, 3, 4 elements. We print out the sentence, and then we use a simple print to print hash map. Do you remember? You can just use print to print الset والarray list. Similarly map. بنفس الطريقة الماب ممكن نستخدم فقط الprint to print the contents of it. Then they ask us to print a name that has an age bigger than 30. But before that, they ask us to print the age اللي حق لويس. How we can do this? Luis is the key. How we can get a value associated with that key? We put a name of a variable that get, and then we send the key. So Luis is the key now here. And it's going to return the value. And what's the value? The value is going to be an age. So what is this sentence going to give us? Luis is 29. So this is going to return 29. After that, we would like to print a name of people age حقهم more than 30. So we will have for loop, which is go for each element. So here we're going to get the keys. Keys are the names in this way. And why we having the key string? So it is going to be string for each string. So we having the key. We will go over it. First, we will have Smith. We will test hash الماب dot get الكey. So الكey is Smith in this way. But this is going to return us what? It is going to return us 30 in the first time, right? Is 30 bigger than or equal 30? It's true. So then we're going to print. This is supposed to be the key. So we're going to print Smith space hash map that get, it is going to be 30. Next time, we will go back. We will have Anderson has key set is going to return us Anderson. If has الماب that's the key, and the key here is Anderson. We send Anderson. This is going to return us what? 31. Is 31 is bigger than or equal 30? True. So now we're going to print the key, which is Anderson space and the hash map that's the get. And when you send the key, which is Anderson, this is going to return 31, and so on and so forth. Later, they ask us to do it in order. To do it in order, we're going to use the tree map. Okay? The tree map, and it's going to have a similar key value, but we're going to send it. What's the value is going to be inside it? The hash map, the one that we just created. To print it out, we just get to use straightforward print. Okay, so this is the output for this one. First, when we have a hash map, it is going to print them. When you use, in this one, we use print line, the street print line. We figure it out, Louis age, and then we would like to print the people, the names has age bigger than or equal to 30, and here you go. You have the key and then the value, and this is the last one here. It is going to do them in order. Whenever you print the tree map, it is going to put the key equals to the value. The last exercise, and we will do so when we will finish soon. Okay, don't worry. It is going to count the occurrence of word in string. If you have any string, you would like to count how many times the word are occurred inside this string. So let's see the code. We have a text string you created to have whatever. So they create having good morning, have a good class, and so on. Now we're going to create a variable called map, and it's going to be tree map. Why? Because here they ask you to having it in ascending order. Yes, Nasreen, you can. Okay? Because they ask us to having it in ascending order, we're going to use the tree map right away. We ask ourselves how we can get the word one by one. If you remember before, we use this in one of the meetings. You can create an array with a word. Yes, you can, Ru'a. If you have a class, you can leave. We're almost done. We're creating an array. For example, here we called it words. How we get it word by word? We put a text, whatever it is, dot split, and this is mean you get it word by word and inserted inside the word. So for example, good going to be an index 0, morning is going to be an index 1, and so on and so forth. Okay? Now what we would like to do, we would like to go over a string. So string is an array with a type string. Okay? Sorry, the word is going to be an array with a type string. So we'll go from the beginning, from 0 to 1, until the length, until the end here. What we would like to do, we will use this, for example, a good, as a key. We'll go to the word, so it has 0. At the beginning, it's good. For example, when I is 0, we having a good. To make sure we count every word, regardless if it's capital or small, we're gonna to convert it to lowercase. You can do it to lowercase, to uppercase, just to make sure you count the same word regardless if it's capital or small. For example, if you don't do this, it is gonna to count the good here, not similar to this good. But when we convert it to lower case or to uppercase, both of them, it is going to be similar. Okay? So now, if the key, for example, a good now, that's a length bigger than 0. That means it's not null. That means a word is not null. If it's not null, that means it's a word. The map contains the key. What does that mean? It contains the key. When you said contains the key and you send the key, I send the good, it is going to return true if it already exists and false if it's not. So for example, if I reach here and I said a map that contains the key, it is going to return true, which is already exists. So it's going to be false, because we use not. If it's already exists, it's going to return true. And the not of a true is false, so it's not going to put it. However, at the first time, when we having a good, a map that contains the key, it is going to return false. Not a false to the true. So it's going to go to the map and put a key, which is a good, and 1. Good? Else to what? So if it's not true, so if it's not the first time we have it, that means it's already exists. So in the first here, in the second case, this is the second time I see good. That means I need to increment. It's not only one time. We see it more than one time. I'm going to create a value as an integer, and I would like to get a variable that is already assigned with this key. For example, here I have a good. Okay? When it's go to good, the first time it's going to be 1. When it's go to it, this going to return, this sentence going to return 1. So the first time it is going to have 1. And the second time when I reach good, it is going to add a value to 1, and it's going to increment it, and it's going to be 2. Now I need to update the map. So I'm going to put in the place that I have a good, the new value, which is 2. That means I find the good 2 times. 2 times in this case. Okay? And finally, we're gonna to just print out. We will go for each as what we explained it, and we print out the key and how many times we find it. This is what will get us A, we find it 2 times, the class we find it 1 time, the fun, the good, and so on is going to return how many times we find each word. This is the last slide. They just need us to remember the things that I showed to you at the beginning, guys. And the collection framework is different than the collection classes. We saw it in meeting 4. Okay? So the collection framework has two roots, الانترفيس والcollection. الcollection والmap. الset والlist والqueue are sub-interface من الcollection. And we need to distinguish between الcollection interfaces اللي شفناها والcollections classes اللي استخدمناها مع الarray list, for example, which has the reverse to sort and so on في meeting form. You didn't use the collection interface method directly, you use a sub-interface. يعني for example الcollection حنا ما استخدمناها, we used the set, we used the map, and we cannot even, we use the sub-interface as an interface type. بس في declaration حتى الانترفيس sub-interface ما نقدر نستخدمها. We have to have concurrent class مثل الهاش set, الهاش map, الtree set, الtree map, and so on. Okay, so that's it. هذه الcollection sort هي هذه اللي جاية من الcollection class اللي شفناها we saw it during map meeting 4. Okay, and that's it for today. Sorry to keeping you longer. Please let me know if you have any question. Yes, you can go, Maria. If you don't have any question, you can leave, guys. Any question about today's lecture? Sorry about finishing it so fast at the end. اللي ما عنده استفسار ممكن يمشي. الله يعطيكم العافية. Yes, I will, Yazid. It's a good question, Yazid. It's already explained الأشياء اللي المفروض أنكم تعملوها بالنسبة إلى TMA. One thing only, يعني أنا ما أقدر أشرح لكم تفاصيل, هي already موجودة, بس بخصوص طريقة الإرسال إن شاء الله راح أتكلم عنها بكرة في المعمل, خاصة للي ما عندهم فكرة كيف يعملوا composite project, إنهم كيف راح يرسلوه. إن شاء الله راح أتكلم عنه بكرة بالمعمل. إيش تقصد بالإنتراكتيف؟ المفروض انك تحط الكود كله, يعني تعمل الكود حقك كله, وبعد كذا راح تعمل له كومبوست, يعني تعمله كزب فايل, ومن جهتي راح اعمل له رن. ف either way انت قصدك ان هي مثلا لو كان في اسئله, هل هي راح تكون هارد كودد, ان هي مثلا الاسم تكتب الاسم كسترينج, او انك تطلب من المستخدم يدخلها, either way it's fine. It's depending, and I don't mean it's fine, it's depending on the question. إيش هو طالب منك السؤال أنت تعمله. أنا من ناحيتي it doesn't matter. اللي أقصده إني لو أنت عملتها hard coded, إنك حطيتها داخل الكود, راح أشوفها. ولو عملتها إن أنا يعني أدخل القيم, in the same time I can do it. So إيش هو السؤال طالب منك, اعمل فيها و don't care about كيف أنا راح أعمل لها running. I cannot unfortunately explain الهومورك. سؤالك جميل أسيل, هذه راح أشرحها بكرة. So ضروري you're supposed to be there. راح أشرح لكم exactly كيف ترسلوا الكود. بالنسبة إلى النسخ تنسخيها وتحطيها بالوورد, بس بعد كذا نفس الكود نفسه لازم تعملي له زب فايل من نفس NetBeans for example وترسليها. اوكي, اقدر افتح لكم الصوت if you have any question guys. اللي ما عندهم سؤال ممكن تطلعوا, يعطيكم العافية. لا مش برنت سكرين للكود. برنت سكرين يا يزيد للاوتبوت. انت لو حطيت برنت سكرين للكود راح تخسر درجة، راح نتكلم عنها ان شاء الله بكرة. تمام. يعطيكم العافية. لو ما في سؤال يس مش مشكلة يا زين، أنا راح أتكلم عنه بكرة إن شاء الله.